Hi, we were discussing about calculus. Let us see the meaning of differentiation here. This is another important thing to understand. We started, remember the way we started differentiation? We started it like this. There is a function f of x. Okay, we took 2 points B and we took another point A. We wanted to find the change in f of x in this point. So what we did f of b minus f of a by b minus a, and we call this as average change in f of x in the interval a comma b. Correct? Then we extended this average change and we got f dash of x to be limit h tends to 0 f of x plus h minus f of x by h. And what is this? This, if we observe closely, see here what is f of b minus f of a by b minus a? This is average change because I am doing it over a big interval. And this f dash of x is nothing but I am doing it again. I am doing the same difference by the length of the interval, but it is for a small region, very small region here. So if this is the average change, what is f dash of x? This is nothing but instantaneous change, because it is going to give me, okay, let me write it clearly, instantaneous change. That is what is the meaning of f dash of x. Okay, now let us take some known function and see what does this instantaneous change conveys to me. Okay, so for example, let us take a complete sine wave and analyze it. So let me plot first f of x here. This is f of x is equal to sine x. Correct? Then what is f dash of x? F dash of x we know, right? Sin x differentiation will give cos x. Correct? Now let us find that graphically. What is happening? I take a point here. Let us prove that f of x is sin x, means f dash of x is cos x by graphical method. Okay, let me take some standard points here. Let me take this many points and see what is happening. What do I mean by f dash of x? I am taking changes in f of x. Correct? So this will be, here I start the change here by the change in x and the change in f of x. What is the value? Similarly, what is the change in x? What is the change? What is the change? So if you see, let me say that all these are equal intervals. Let me say that, for example, this, this all are equal intervals. That is, if this is 1, this is also 1, this is also 1, this is also 1, like that. All are equal intervals. Now if I see what is f dash of x, the value between the change, this value minus this value divided by this will give me the change. Again in this interval it will be this value minus this value divided by the length of this interval, correct? So observe one point, the change in x axis is always same, but the change in along y axis are different. Okay, if I draw for understanding sake the first half portion alone here of the sine wave, for understanding I am redrawing it, and these are all equal intervals which we have taken. Now observe that x, the change in x here is same as change in x here, 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 everywhere. But observe the change in y here. Y is changing so much here, then the change in y is less, then it is further less, then it is increasing in the opposite direction, correct? So till this point, the second value was bigger than the first value. After this point, after this here, the first value is bigger than the second value considered, because this value is bigger than this value. Similarly this value is bigger than this value, correct? So the direction of change, there will be a negative sign here. See, for example, if I will be doing first value minus second value, correct? Sorry, second value minus the first value, correct? So if I do this value minus this value, I get a positive difference. Whereas when I do this value minus this value, I will get a negative difference, because the first value is more than the second value. So at this point, at the peak, after the peak the direction changes. After the peak, till here I will get positive values, after here I will get negative. And here also the positive value is in decreasing trend and the negative values are in increasing trend, correct? Positive value is in the decreasing trend. So there was positive values but less positive values, then we get negative values, correct? Again see this, we have equal intervals in x here, okay? The negative values are increasing more and more, correct? Till this point I see always the second value is lesser than the first value. So I keep on getting negative values till this point. After this point, the value finally approaches minimum. And then we see that again the negative second value is greater than the first value. We see a positive differences now. After this point, we start seeing positive differences. It goes like this. So when I reconstruct that, I observe that this is a cosine wave, correct? This is how the cos wave looks, right? So this is, we are proving the derivative of f of x is equal to sin x as cos f dash of x will be cos x in a graphical fashion. Similarly, if I do this again, if I do the derivative of cos x, I will get minus sin x. It will be like this. I get a minus of sin x. This is, I call the derivative with respect to f of x. It is f double dash of x. It is nothing but f dash of x. That is called f double dash of x and differentiated twice. Now let us observe some interesting results here. when the function reaches a maximum, this is the maximum value, correct? Please observe, this point is the max value of sin x. Similarly, this value, this is the min value of sin x. And when I see that both at max value and min value, f dash of x is 0. So f dash of x is 0 means the f of x is either max or min. Now how do I know whether which is max, which is min from this? F dash of x is 0 means at that point f of x is either max or min. So how do I conclude it is max, or how do I conclude that it is min? I observe f double dash of x. We have the another clue here. At the maximum point, this is the max value point, right? This is the max point, right? At the max point, f double dash of x will be negative. At min point, f double dash of x will be a positive value. These are very important conditions to remember. This is just seeing graphically how to do the find the graph f dash of x for f dash of x is equal to sin x if f of x is equal to, f dash of x is cos x if f of x is sin x. This we saw graphically. Now let us, and we made some few important observations. Now let us do some graphical analysis for a general function. Let me take this as the x-axis. Okay, let me first draw a random function like this, some function, and I'm going to do the same thing. I'm going to take equal intervals in x, equal intervals in x, and see how is the variation. Okay, now if I take these values, this is some random function I have plotted, and I am taking equal intervals in x. That is, this interval is this, each and every interval is same. Now if I try to plot in this interval, I see that the second value will be bigger than the first value, so I will get a positive change here, and the change will, this keeps on reducing and finally approaches here to a constant 0, and the value will approach 0 here. It approaches 0, then the slope, this part of the curve, I see that the second value is lesser than the second value is less than the first value, so I will get a negative slope. Again at this point it will drop to 0, then again it will drop to 0, then it keeps going. Again I see it drops to 0, something like this I will be getting. This will be the way the f dash of x looks. And if I plot f double dash of x, f double dash of x will look, f double dash of x is nothing but f dash of x, correct? So that will be having the changes of this curve plotted. Again I take equal intervals here, and if I complete the plot, I leave this portion for you guys to complete, I want you guys to complete it for this portion and analyze it. And if I find the f double dash of x, again we see that we will definitely see at this point this will be this function, this part is having a negative slope, right? This is a negative slope. This is having a negative slope, correct? So this will result, this part will result in a, here we will get a negative waveform. Here this value, in this region the value of f double dash of x will be, f double dash of x will be negative. Similarly, if you see, this point here is a max value, and again we see the corresponding point in f double dash of x is having a falling slope, negative slope. So f double dash of x again in this region will be negative. Now let us take a mean point here. This is a mean point. Similarly, this region is a mean point. In this region, if you correlate with f of x, this is having a, here we are having a positive slope in this region. So this will be resulting in a positive value here. So we finally conclude that for any function f of x, if f dash of x is equal to 0 and f double dash of x is negative, say at some point, then that point is a what? Max value. Similarly, if f of x, f dash of x equal to 0, f double dash of x is greater than 0, that is f double dash of x is positive, then we can say that then at that point f of x is minimum. This is very important conclusion. Let us see couple of examples related to this. First, let us take a well-known example. Okay, let us take y equal to sin x. Find max and min values of y equal to sin x in 0 comma say 2 pi. We already know the answer, but let us evaluate it. The max value will occur at pi by 2 and min value will occur at 3 pi by 2. This will be the max value, this will be the mean value. But let us evaluate using this method and prove that we are correct, and let us check that our results are correct. So first thing is f of x is equal to sin x. So f double dash of x will be, sorry, f dash of x will be cos x, and f double dash of x will be minus sin x. Now f dash of x is equal to 0. At what point f dash means cos x is equal to 0. That means where it will happen, x is equal to n pi by 2. correct? And we are evaluating up to 2 pi only. So x can be pi by 2 or 3 pi by 2, correct? Now f double dash of x is minus sin x. So f double dash of, we evaluate f double dash at both the points. What is f double dash of pi by 2 and what is f double dash of 3 pi by 2? At f double dash of pi by 2, sin pi by 2 will be 1, but minus sin pi by 2, so we will get minus 1, because here f double dash of x is having a minus sign, remember that. And f double dash of 3 pi by 2 will be, sine of 3 pi by 2 is minus 1 and minus of minus 1 will be a plus 1. So this is a positive value and this is a negative value. So at pi by 2, at pi by 2 we have f dash of x equal to 0 and f double dash of x less than 0. At 3 pi by 2 we have f dash of x equal to 0 and f double dash of x greater than 0. So which proves that pi by 2 is a max value and 3 pi by 2 is a min value, which is according to our understanding. So our results are correct. Let us continue. Okay. Let us solve one problem. Find the max and min values of f of x is equal to x square in minus 2 comma 1. Okay, so let us go by that. F dash of x will be 2x, f double dash of x will be, f double dash of x will be 2. Correct? Now we see that for max or min value, f dash of x equal to 0. Correct? We have seen this. Therefore f dash of x is equal to 2x and this has to be 0, which will imply that x is 0. And we have a constant value, a constant positive value, which implies that in the given interval f of x has only what? Minimum value, and that is at x equal to 0. This is the solution. So there is no max value, only min value exists, that is at x equal to 0. Okay. Just a second, let me resolve this. Okay, it's recording. Okay, let us solve one more quick problem. F of x is equal to 8x minus x power 4. Find max and min values in interval minus 2 comma 1. So the first condition, first thing is we have to find f dash of x. What is that? It is 8 minus 4x cube, and this has to be always, whenever we find, equate to 0. Okay, so 8 minus 4x cube equal to 0 implies x cube, 4x cube is equal to 8, x cube is equal to 2, x is equal to 2 power 1 by 3. Correct? Now, what is f double dash of x? We have to find this, because we cannot conclude anything from f dash x equal to 0, because we have seen that both at maxima as well as at minima f dash x will be 0. So we have to find f double dash. What is f double dash of x? It will be, we have to define f double dash of x is nothing but f dash of x. This is nothing but f dash of 8 minus 4x cube. This is nothing but minus f dash of 8 will be 0. So we'll get minus 3 into 4x power 2. That's a minus here. 3 into 4x square. This is nothing but minus 12x square. In the given interval, please observe this again. This is again a tricky problem. In the given interval minus 2 comma 1, this is a real number, right? All are real numbers here. All are real numbers. So x square is definitely going to be positive always, because we are talking about real numbers. Correct? So minus 12x square will always be a negative number if x is real number. Correct? So again we conclude that in this region f dash of x is 0 at 2 power 1 by 3, and f double dash of x is always having a negative value. That means what? F double dash of x is less than 0 and f dash of x equal to 0 at x is equal to 2 power 1 by 3 implies x equal to 2 power 1 by 3 is a max point. Correct? Because f double dash is negative and f dash is 0.